When you think about what makes a modern factory run, it's not just the robots and the heavy machinery anymore. There's this invisible intelligence, this complex brain, trying to make these massive industrial systems run perfectly. But as things get more and more complex, the old ways of doing things, well, they're starting to hit a wall. So let's explore how AI is stepping in to become the new brain behind it all. All right, here's our game plan. First, we're going to look at the classic tools that have been running factories for decades. Then, we'll see exactly how AI plugs into that system. After that, we'll get into AI's awesome new bag of tricks, check out some really impressive real-world wins, and then, and this is super important, we'll wrap up with a crucial reality check on the risks. So before AI even showed up on the scene, industrial automation was already built on this really solid foundation of 3 core control methods. You can think of these as the established muscles that have been doing the heavy lifting in factories for years and years. First up, we've got feedback control. Let's just call it the reactor. It's actually super simple but really powerful. Think about your thermostat at home. It measures the temperature, realizes, hey, it's too cold in here, and then kicks on the heat. See? It's reacting to an error that's already happened to get things back to where they should be. Next, there's feed-forward control, or the predictor. This one's proactive. It tries to get ahead of the game. Imagine a chef who knows they need a scorching hot pan to get a perfect sear on a steak. They preheat that pan way before the steak gets anywhere near it because they're anticipating what's needed. It acts on what it thinks is coming. And finally, there's Model Predictive Control, or MPC. This is the optimizer. Honestly, the best way to think about this is like your car's GPS. It doesn't just know your destination. It has a whole model of the roads. It's predicting traffic jams, and it's constantly, and I mean constantly, recalculating the absolute best route for you in real time. It's always looking ahead to find the most efficient path. So let's just put that all together real quick. Feedback control is reactive, always asking, am I on target right now? Feed forward is proactive, asking what's coming down the pipe. And MPC is predictive, asking what's the absolute best path forward. But when you line up their biggest weaknesses, you see the problem. One reacts too late, one can't handle surprises, and the other is totally useless without a perfect model. And that gap, that's exactly where AI comes into play. So how does AI actually fit into this whole picture? Well, it's not really about ripping out all those classic controllers and starting from scratch. Instead, AI is usually layered right on top or even integrated inside, acting as this powerful new layer of intelligence that guides those old, reliable muscles. And this tends to happen in one of 3 ways. First, the AI can be the supervisor. Kind of like a manager who figures out the optimal production targets and just tells the traditional controllers what to do. Second, it can be embedded in the loop, where it's the one in the trenches making direct, real-time control decisions all by itself. And third, it can be the hybrid helper, working side by side with the classic systems to tackle the really messy, complex problems they just can't handle on their own. Okay, so what exactly gives AI these incredible new powers? It's not magic, right? It's a whole new toolkit. These are AI's new tricks of the trade, and they're all driven by specific machine learning models that are totally changing the game for industrial control. And this toolbox is packed. You've got things like random forest, which is built for making super fast data-driven decisions. Then you have deep neural networks, which are amazing at understanding these incredibly complex, messy relationships in data that don't follow a straight line. Others, like LSTMs and transformers, are like forecasting wizards, perfect for giving that predictive control we talked about a serious upgrade. And then you've got reinforcement learning. This is the one that learns by trial and error, kind of like playing a video game over and over to get really, really good at juggling multiple, often competing goals all at once. Okay, this all sounds amazing in theory, but where's the proof? Where is this stuff actually being used? Let's take a look at some real-world wins where these AI controllers are delivering some seriously impressive results. Okay, so in manufacturing, you have these things called CNC machines. They're basically computer-controlled cutting tools. Well, with AI driving them, they can adjust their own speed and pressure on the fly. And the result? They cut through material way faster, and the cutting tools themselves last a whole lot longer. That saves a ton of time and a ton of money. Or what about getting a perfect weld every single time? This is so cool. By pairing deep learning with ultrasonic sensors, an AI can essentially listen to a weld as it's being made. It can hear tiny problems in real time and make adjustments to ensure the final connection is super strong and reliable, which, as you can imagine, is absolutely critical for safety and quality. Now let's talk about the high-stakes world of pharmaceuticals.
Here, consistency is everything. There's zero room for error. So AI uses all this real-time sensor data during the manufacturing process to constantly tweak and adjust things. And this makes sure that the final drug quality is rock solid and meets all those strict regulations. Now, this chart shows a really clever win. A controller using deep reinforcement learning, that's the trial and error method, was trained to manage a system of rainwater pumps during a storm. The result was incredible. It drastically cut down on how often the pumps had to switch on and off, which saves a ton of energy and prevents wear and tear, all while still hitting its other critical performance targets. That is a massive win for efficiency. But hold on a second. Putting an AI in charge of a massive physical system, that's not something you do casually. We absolutely have to talk about the very real risks and the huge challenges that come along with all this new power. And look, there are some major hurdles here. First, latency. Speed is everything. These decisions often need to be made in fractions of a second. Then there's safety. This is non-negotiable. You have to be able to predict what the AI will do, and you have to test it like crazy in simulations before it ever touches real hardware. On top of that, these systems are a huge target for cyber attacks. And finally, believe it or not, the official rules and regulations for how to certify these AI systems, they're still being written. So, what's the big takeaway from all this? It's that AI in these control systems isn't just some fancy new tool. It's a fundamental upgrade to the entire brain of an operation. And with that kind of power comes an absolutely immense responsibility to roll it out safely, securely, and very, very thoughtfully. And that really leads us to one final critical question. The technology's here, and it is moving forward at a mind-bending pace. It promises this incredible future of super-efficient, self-optimizing factories. But when you weigh that incredible potential against the really serious risks, you have to stop and ask, are we truly ready for factories that think for themselves?